In Inventon, the Institute of Chemical Technology and Downstream Chemicals Technology Station is one of the Nelson Mandela Metropolitan University's leading research and engagement entities. Inventon's Microalgae to Energy, or MA2E project, has been in progress over the last 4 years. Funded by the NMMU and the National Department of Science and Technology's Biofuels Demonstration Program via the Technology Innovation Agency, the project is ready for commercialization. The MA2E project, which comprises several focus areas around the cultivation and use of microalgae biomass, has had several technical breakthroughs over the past 30 months, including the development of a new photobioreactor, or PBR system, for the large-scale cultivation of microalgae that promises to be both technically and economically viable. The PBR system incorporates several unique characteristics, including a simplified microalgae harvesting methodology that exploits the rapid consumption of dissolved carbon dioxide by actively photosynthesizing microalgae. The recovery of waste or discard fine coal by adsorbing microalgae onto the surface of the fine coal and using the microalgae as an effective binder for such fine coal. Beneficiation of discard coal from a low-quality fuel to export-grade coal by demineralizing the fine coal using the microalgae's selective binding to only the coal particles. Providing a significantly improved solid fuel for energy generation by forming coal microalgae composites, or Coalgae, due to the faster combustion rates, higher combustion temperatures, and more complete combustion of these composites compared to coal. The production of a high-quality biofossil crude oil blend from Coalgae, whilst at the same time producing a high-quality clean coal, which is devolatilized and desulfurized. The biofossil crude oil blend is ideal for the production of various drop-in biofuel blends such as gasoline, diesel or kerosene, aviation fuel, and heavy fuel oil. The development of a continuous direct liquefaction process for microalgae biomass to produce a biocrude oil for further conversion into chemicals and liquid fuels. Microalgae offers great promises to contribute a significant portion of the renewable energy that will be required to meet global requirements. Furthermore, microalgae fuels could prove to be sustainable for generations. They consume carbon dioxide as a nutrient, have a much higher yield potential than other terrestrial biomass feedstocks, and can be grown with non-fresh water sources without needing to use high-value arable land. Despite the many resources devoted worldwide to microalgae commercialization over the past several years, a scalable, commercially viable system has not yet emerged. It is believed that the NMMU Coalgae technology, after proof on a demonstration plant, will be the first in the world to offer a scalable and viable system. This technology is the first aimed at using microalgae biomass at low mass ratios for coal fines or discard beneficiation, and extracting maximum benefit from the coal microalgae composites formed in the process. As a result, economic viability of this technology is not solely dependent upon the microalgae biomass component in final products. Other applications of algae can be developed after proving the algae production technology and primary product production at a demonstration scale. South Africa, despite its relatively low economic ranking, is one of the top 20 major polluters worldwide and is one of the top 5 polluters among developing nations. The dependence on coal for its primary energy needs, electricity and fuel, is a major contributor to South Africa's relatively high emissions. This research has been stimulated by concerns about global climate change brought about by the burning of fossil fuels. As a result, in an effort to reduce greenhouse gas emissions, many countries, including South Africa, have enacted mandates or targets for renewable energy production and consumption. Furthermore, carbon taxes have been introduced in a number of countries, and carbon taxes should become effective in South Africa in 2016 at an initial rate of 120 Rand per carbon dioxide ton, above an agreed baseline level. Microalgae cultivation in closed photobioreactors has been demonstrated in a pilot plant facility at Inventon NMMU in Port Elizabeth for about 3 years. The system has proved robust, and a number of iterations of the photobioreactor design have been introduced to optimize the design and efficiency of the system. Several other coal algae product and process applications are being investigated at Inventon. Amongst the most promising at this stage is a pyrolysis of the coal algae mixture. The process has been developed on a small pilot scale and is technically feasible. Initial results reveal that a high-quality bio-derived crude oil fraction is obtained in relatively high yield, and that the char co-product could have high-value applications. Innoventon has shown that microalgae can be rapidly absorbed onto the surface of carbonaceous material such as coal and charcoal. Once adsorbed, microalgae acts as an excellent binder for fine coal at microalgae biomass loadings at 5% biomass on a dry weight basis, without the need for any other additional binding material. Higher biomass loadings are possible, and the choice of loading will depend on the product application and customer requirements. The product, called Coalgae, may be prepared in various solid forms, for example, granules, briquettes, pellets, or extrudates. As shown, Coalgae exhibits excellent mechanical and water resistance properties.
One of the problems in coal processing, and perhaps the biggest problem facing the coal processing industry today, is a beneficiation of fine coal. Because it cannot be economically beneficiated in the time available to make this happen properly, this coal is often discarded. It is typically, the quality of it is typically that of the raw coal in the ground, give or take 1 or 2 megajoules. This coal's left and hardly anybody uses it at this point in time. It is a discard product. The reason it's not used in Eskom is because of the moisture content of that coal, which makes it very difficult to handle in conventional materials handling systems. It is not a high enough grade to be exported, and therefore is simply left in slurry ponds or pumped back underground in certain cases. On occasion it might also be co-disposed with the coarse discard on the coal mine. The advent of Coalgae, which is a mixture of algae and fine coal, has on the one hand allowed for some of this coal to be beneficiated and upgraded, but has equally created a novel product with unique properties which will find use in both the combustion and certain other niche markets in the energy sector.
Coalgae is a direct substitute for coal in the vast majority of its applications and adds a renewable energy fraction to the consumer's operations, imparting increased environmental sustainability to the business and reduced emission taxes, if applicable. Its use requires no process or equipment changes. Moreover, the ability of Coalgae to demineralize poor quality discard coal selectively is an important competitive advantage of the process that allows recovery of significant value from waste and poor quality coals.
I'll use some figures from the International Energy Agency, a report published in 2011. Globally, we're looking at around 58 gigatons of waste coal that is already stockpiled. So that's 58 and 12 zeros after that. In South Africa, we're talking somewhere between 2 and 3 billion tons that is lying there. Globally, we add roughly 1.1 billion tons of waste coal to that stockpile every year. In South Africa, that's close to 50 million tons that we're adding. So if we take the South African scenario and let's say we can convert all of that waste using the algae, then we can make in the region of 20 million barrels of crude oil, which is roughly 60% of our oil imports into this country, around 3 million tons of LPG gas. So that's enough to supply basically all of the households in South Africa with LPG and run of that. And on top of that, we will have a residual fuel, a solid fuel, a clean coal, which virtually burns smokeless.
Extensive effort has gone into developing an engineering design that is cost-effective, buildable, scalable, operable, and maintainable, particularly with respect to the photobioreactor. The main processes of the plant design are the growth system, which goes on to harvesting. This then moves on to the coal and algae mixing and de-ashing. These go to waste ash handling. proceeding to dewatering and agglomeration, moving along to final product handling. NMMU's technology using microalgae to recover, upgrade and agglomerate fine coal is superior to anything reported to date. This is true not only in terms of the superior mechanical and weather resistance properties of the agglomerated fine coal, but also due to the substantial synergistic effect of the microalgae biomass on the coal in its final application, whether the application is combustion for energy generation, energy for home usage, gasification or pyrolysis. While many entities are pursuing algae processes mainly for biodiesel, none are specifically aimed at beneficiation of discard coal. The microalgae to energy technology concept has the potential to become a world-leading technology for the production of energy in an economic and sustainable manner. The project complements the South African government's national policy on climate change and Millennium Development Goal 7 through reducing greenhouse gas emissions, promoting environmental sustainability, and improving the lives of people through the creation of jobs. It aims to provide a solution for biofuel production and renewable energy by beneficiating discard coal using microalgae to produce bioenergy-related products, including Coalgae, coal algae composites, and Zyhoil, bio-crude oil. The microalgae cultivation technology has been demonstrated at a pilot scale, while Coalgae and Zyhoil production have been demonstrated at a smaller scale. The next step is to integrate the technologies at a demonstration scale of 1 hectare. NMMU, through Innoventon, has established a critical mass of expertise and equipment to drive the research agenda for microalgae to energy.